Hello friends, I welcome you in lecture number 18 on higher order ordinary differential equations. In this lecture also we are going to discuss one more example on the method of undetermined coefficients. In this example, the right hand side of given equation is addition of polynomial function, exponential and sine function. So we will see how to find out particular solution using this method if we have addition of more than special functions on the right hand side. So first we find out the complementary function by writing the corresponding homogeneous differential equation. So as we know, if we consider right hand side equal to 0, we will obtain the corresponding homogeneous ordinary differential equation. The corresponding homogeneous ordinary differential equation is left hand side of given equation is y triple dash plus y dash, and we consider right hand side equal to 0, and we solve this equation. First we write its auxiliary equation. The auxiliary equation is lambda cube plus lambda equal to 0. So here we can take lambda common, so we have lambda times lambda square plus 1 equal to 0. So therefore lambda equal to 0 and lambda square plus 1 equal to 0. This we can rewrite as lambda square equal to minus 1, and minus 1 is nothing but I square. So from this we obtain lambda equal to plus or minus I. So we have one real root and two complex roots. This is a pair of complex roots with real part equal to 0. If we compare with 0 plus or minus I with alpha plus or minus beta I, say, then alpha is 0, beta is 1. So therefore first we write down the complementary function. The complementary function is y suffix c equal to corresponding to lambda equal to 0. The part of complementary function is c1 e raised to 0x, and corresponding to this alpha equal to 0, beta equal to 0, we have c2 e raised to alpha x, that is e raised to 0x, cos beta x, that is cos x. Similarly c3 e raised to alpha x sin beta x. We put alpha equal to 0, beta equal to 1. Therefore complementary function becomes c1 e raised to 0 x is 1 plus c2 cos x plus c3 sin x. So this is the complementary function of given non-homogeneous differential equation. Now we concentrate on the right hand side. So right hand side is, first we write down the right hand side of given equation. Here rx means function on the right hand side, 2x square plus e raised to 2x plus 4 sin x, 2x square plus e raised to 2x plus 4 sin x. Let me check again. 2x square plus e raised to 2x plus 4 sin x. So now first we have to find out the family of derivatives corresponding to this right hand side. So for that we have to first write the family of derivatives corresponding to each function, and then we will take their unions. So the family of derivatives corresponding to 2x square is 1x x square. The family of derivatives corresponding to e raised to 2x is e raised to 2x only, and the family of derivatives corresponding to this sine function is sin x cos x. And the family of derivatives for this addition is nothing but union of all these families. But before taking union, we have to check for each family that whether any member of a family is present in the complementary function or not. So we check one by one. So here we can see in this family we have 1x x square. So here 1 is present in the complementary function. So we have to modify this family by multiplying by x. So if we multiply by x, this family becomes x square and x cube. Again we check whether any member of modified family is present in the complementary function or not. So now there is no member of this family present in the complementary function. So this will be the correct choice for this function 2x square. Now for this function, family is containing only one function e raised to 2x. So it is absent in the complementary function. So this will be the right choice. Now for this function, family contains two functions sin x and cos x. But sin x is present here. So we will modify this also by multiplying with x. So this is x sin x and x cos x. Now there is no member of this family present in the complementary function. So whenever more than one functions are in the union, first we have to write their corresponding families, then we have to check whether any member of each family is present in the complementary function or not. If a member of some family is present in the complementary function, then we will modify that particular family by multiplying with x, as we have modified these two families, and we will keep other families as it is, and we will take union of modified families. So the union of modified families is family for 2x square is x square x cube. Family for e raised to 2x is e raised to 2x, it is as it is, and here modified family is x sin x comma x cos x. So union of these three sets is nothing but x square x cube e raised to 2x x sin x x cos x. Union means the members which are present in either one set or two sets or three sets or in all these three sets. So we are writing all the members in the one set. So this is the union of these three family of derivatives. So now we can assume our choice for particular integral. So now we assume that particular integral or particular solution is yp equal to linear combination of all these functions. So we consider a into x, b into x square plus c into x cube plus d times e raised to 2x plus e times x sin x plus f times x cos x. So this is the proper choice for particular integral or particular solution corresponding to given right hand side. Now yp is solution of this equation, so it will satisfy this equation. So we will have yp triple dash plus yp dash equal to this right hand side. So we will require first and third order derivatives. So now we differentiate this particular solution with respect to x. So yp dash derivative of a into x is a plus yp double dash b, as it is derivative of x square is 2x, so we have 2bx. Similarly derivative of x cube is 3x square, so we can write 3cx square plus derivative of e raised to 2x is e raised to 2x into 2, so we have 2 times e raised to 2x into d. Here two functions are in the product, so we have to apply multiplication rule. So we consider x as it is derivative of sin x is cos x plus sin x as it is derivative of x is 1. Same thing here, by product rule we have f times, if we differentiate x first, cos x as it is derivative of x is 1, and if we differentiate cos x, derivative is minus sin x, and we have negative sign here, x remains as it is. we require third derivative, so we have to go for second and third derivatives. Yp double dash, derivative of a is 0, derivative of 2bx is 2b constant as it is, derivative of x is 1, 3c as it is, derivative of x square is 2x, so we have 6cx. Here we will have e raised to 2x into 2, that 2 will multiply with 2d, and we have 4d e raised to 2x. Here we again have to apply product rule. So first derivative of x is 1, e cos x as it is, derivative of cos x is minus sin x, e into x as it is. Here derivative of sin x is cos x, so e cos x, derivative of cos x is minus sin x, so we have minus f sin x. Here first we differentiate x, so we have sin x as it is, and then we keep x as it is, derivative of sin x is cos x. So this is second derivative. We again differentiate with respect to x, so yp triple dash equal to derivative of 2b is 0, it is constant, derivative of 6cx is 6c as it is, derivative of x is 1. Here derivative of e raised to 2x is 2 times e raised to 2x, so we will have plus 8d e raised to 2x. Here we can have addition of these two, which is 2 times e cos x. Okay, I can remove this, and here I can write twice e cos x. Similarly here I have f sin x 2 times, so I can remove this part. Okay, so that will reduce my work. So derivative of cos x is minus sin x and 2e as it is, and we have negative sign, and here we have to apply product rule. First we differentiate x, so e sin x as it is, and then derivative of sin x is cos x, ex as it is. Now derivative of sin x is cos x, so we have minus 2f cos x, and again we have to apply product rule. Minus f cos x as it is, derivative of x is 1, and derivative of cos x is minus sin x, so we have negative negative positive, f x as it is, derivative of cos x is minus sin x. So let us see whether we can combine the terms. Here we have e sin x. Okay, so we can rewrite by combining the terms. 6c as it is, there is only one term with e raised to 2x. Sin x is minus 2e minus e, so we have minus 3e sin x. Cos x is minus 2f cos x minus f cos x, so minus 3f cos x, and here minus ex cos x plus fx sin x. Okay, fine. So we have found the derivatives required for given equation. Now we substitute yp in the given equation, because we have assumed that yp is solution of given ordinary differential equation. So yp must satisfy given ordinary differential equation. Given equation is y triple dash plus y dash, so we substitute yp for yp triple dash plus yp dash. So here we substitute yp instead of y, and right hand side is 2x square plus e raised to 2x plus 4 sin x. 2x square plus e raised to 2x plus 4 sin x. Let me check again. We have to be very careful. A little mistake can read 2x square plus e raised to 2x plus 4 sin x. 2x square plus e raised to 2x plus 4 sin x. So first I substitute yp triple dash, which we have written here, so that we substitute here 6c plus 8d e raised to 2x minus 3e sin x minus 3f cos x minus ex cos x plus fx sin x plus yp dash. So yp dash is, we substitute this, a plus 2bx plus 3cx square, a plus 2bx plus 3cx square, a plus 2bx plus 3cx square, 2d e raised to 2x plus ex cos x, 2d e raised to 2x plus ex cos x, then e sin x plus f cos x, e sin x plus f cos x, and last minus fx sin x, minus fx, let me check again, fx sin x. Okay, we have to be very careful, a single mistake is okay, fine. And right hand side is 2x square plus e raised to 2x plus 4 sin x. Now let me check whether any terms which we can combine. So here we have e sin x, here we have e sin x, and any other term with sin x. Okay, so that will become minus 2e sin x. Similarly 3f cos x, here minus 3f cos x, f cos x. So these are the two terms with cos x, and we can see ex cos x and minus ex cos x will cancel each other. Similarly fx sin x minus fx sin x will cancel each other, and we can combine these two, e raised to 2x, 2d e raised to 2x, and constant term is, this is constant term 6c plus a, this is constant term. Then this contains x square 2bx, there is only one term with x. Okay, fine. So we can compare the coefficients on both sides. So constant term on the left hand side is 6c plus a, and there is no constant term here, so we can have 6c plus a equal to 0. Okay, so we obtain this one equation. Then term with x, that is 2bx on left hand side, there is no term with x, that means coefficient of x is 0 on left hand right hand side, so we have 2b equal to 0. This will give us b equal to 0. Now we compare the terms with x square. So there is only one term with x square, which is 3c x square. There is no other term with x square, so we have 3c equal to 2. Here coefficient of x square is 2, so this will give us c equal to 2 by 3. And once we obtain c, we can obtain a also, a equal to minus 6 times c, that is minus 6 into 2 by 3. Here we will have 3 cancel out, so a is minus 4, so value of a is minus 4. And now we compare the coefficients of e raised to 2x. So coefficients of e raised to 2x are, here we have 8d plus 2d, so that will become 10d, and here coefficient of e raised to 2x is 1. So comparing the coefficients of e raised to 2x, we obtain 10d equal to 1, that will give us d equal to 1 by 10. Now we compare the coefficients of cos x. So for cos x we have minus 3f cos x, and here f cos x, that is minus 2f cos x, and there is no term with cos x on the right hand side. So we obtain minus 2f equal to 0. So we have f equal to 0, because on the left hand side we have minus 2f cos x, but on the right hand side there is no term with cos x, so minus 2f equal to 0. Then this term e sin x terms with sin x, so this is minus 3 e sin x, this is e sin x, so that is going to be minus 2 e sin x, and here coefficient of sin x is 4, so we obtain minus 2 e sin x equal to 4 sin x, that is minus 2 e equal to 4. So this implies e equal to minus 2. So what is remaining? We have obtained a, b, c, d, e and f. Okay, fine. So we are having all the coefficients, undetermined coefficients. Okay, let me check again whether any term is remaining to compare. So we have to be very careful. We have compared all the terms with right hand side and we obtain these coefficients. So we substitute all these coefficients in the particular integral. Therefore the particular integral is yp equal to we have yp equal to ax plus bx square plus cx cube. What is value of a? A is minus 4, so we have minus 4x. Value of b is 0 and value of c is 2 by 3, so we have 2 by 3 x square. Value of c, okay, so this is 2 by 3 x cube. B is multiplied with x square, but b is 0, so we have 2 by 3 x cube, that is with cx cube. Okay, we have ax plus bx square plus cx cube. This term is going to be 0 because b is 0, and we have substituted values of a and c. Ax plus cx cube, value of a is minus 4, so we have minus 4x, cx cube, that is 2 by 3 x cube, plus d into e raised to 2x, so here d is 1 by 10 e raised to 2x. And then so we have written this ex sin x plus fx cos x. Value of e is minus 2, so we have minus 2x sin x, and value of f is 0, so this is our particular solution. So therefore we can write down the general solution. The general solution is y equal to yc plus yp. Therefore y equal to complementary function was c1 plus c2. Let me check again. Complementary function was c1 plus c2 cos x plus c3 sin x. c1 plus c2 cos x plus c3 sin x minus, we write down this particular integral, minus 4x plus 2 by 3 x cube plus 1 by 10 e raised to 2x minus 2x sin x, where this c1, c2, c3 are arbitrary constants. So in this way we can find out particular integral in the method of undetermined coefficients, even if we have more than two functions in the addition. What we have to take care is we have to write down the families corresponding to each function. Then we have to check for each family that any member is present in the complementary function or not. If any member is present in the complementary function, then we modify that particular family by multiplying with x. So here we have modified these two families and this family remains as it is, and then we take union of these three families, and linear combination of members of this union is nothing but our proper choice for particular integral. So this is all about this lecture. I hope you like it. Thank you very much.